speaker is Suraj. He's a renowned data scientist, YouTube content creator, teacher, MOOC course instructor. I think a lot of you have tried the deep learning course already. He has a mission to inspire and educate developers to build AI. He's also a dApp developer and entrepreneur, founder of a crowdfunding platform for developers called Habi. He developed several iOS apps, including meetup, and then has worked on a host of open source work. Besides that, he likes to travel, he's a musician, postmodernist, and scuba diver. And then I was like tempted to say hello world, something, but I think I'll leave that to, so let's put our hands together and welcome.
Thank you. All right, hi everybody. All right, testing 4876. That's the next code for Bitcoin, so buy it at that price. No, I'm just kidding. Okay, yeah. You know, the end of that description was like this really old description that O'Reilly wrote when I wrote the book Decentralized Applications like 4 years ago, which at the time Hobby was, yes, a crowdsourcing platform that I helped create, but now it's deprecated and et cetera. You know how stuff moves in software. It's just like here and gone in like 30 seconds. But yeah, so this talk is called Decentralized. Let me move out of the way. Let me just get a feel for how this is going to work. Okay, Decentralized Artificial Intelligence. That's the name of this talk. It's really combining two technologies that are very hot today, deep learning and blockchain. We know about these two technologies, right? Even if you're in data science, you study blockchain at some point. There's articles. It's hard not to look at this space with some level of interest. So we're going to talk about how to combine these two technologies together to make something beautiful. So I want to start with a quote by a very well-known public figure, shall we say. The quote is, "He alone who owns the youth gains the future." And this is by Adolf Hitler. I just want you to think about this quote for a second. He alone who owns the youth gains the future. What did he mean by that? Clearly he knew what he was talking about. He was able to influence the youth to kill people by the hundreds of thousands. So I want to ask you guys this question. Who owns the youth? Single word answers. This is an open question. You can raise your hand. Who owns the youth? Facebook. Yeah. Facebook, okay. Really smart guy. Any other
Snapchat.
Okay, you guys know what's up. Yeah. Exactly. Yeah. Facebook, Snapchat, those are some possible answers. But let's talk about what the larger answer to this question is. Who owns the youth? Who owns the future? So in the 80s, the web was created, et cetera, right? The World Wide Web. We know that the web was created, but I remember going to CERN. CERN was in Geneva. I had a talk at CERN in Geneva, and it was amazing. Like the data scientists there, like we were getting so technical. They knew exactly what was going on. Their questions were so beautifully orchestrated. They were challenging me. It was amazing. And those people, I mean, the amount of data that CERN has is amazing. Like, anyway, that's a tangent. When I was at CERN, I remember seeing Tim Berners-Lee's office, the creator of HTTP, the hypertext transfer protocol for the World Wide Web. Arguably, without that protocol, everything that we're doing, carousel, everything about the web wouldn't exist. And I remember seeing his office and just standing there for a second and being like, wow, this is where it all began. And then I backed up for a second and I was just like, oh my God. And all these kids started coming in. I was like, oh, I better back up. And these kids started coming in mass. And they were like, I don't know, 8 or 10 years old. It was like a school field trip. And they came in and they saw, and then the teacher was like, or the guide was like, and this is where the World Wide Web was created. And the kids were like, oh my God. And they took a Snapchat and immediately left. Like they didn't even, like some of the kids just, when the guide said that, they just like kept walking. So that's who owns the future, Snapchat. Right, because the kids use Snapchat. So that was Web 1.0. This man is Web 2.0. Who knows who this guy is? Just shout it out. Jeff Bezos. Who is the richest guy in the world right now? Jeff Bezos. Yeah. In '98, this was Jeff Bezos. He was selling books. That's all he wanted to do with Amazon.com. He was selling books. He had a very, very small office. His office was just a desk, right? And now Amazon is more powerful than Walmart. Its market cap is higher than Walmart. Its market cap is higher than any bookseller in the world, Barnes and Nobles, etc. All of these global brands, Amazon eats them up, literally, quite literally, Amazon acquires them. So Jeff Bezos owns Amazon. He's the largest shareholder in Amazon. And Amazon is just one example. We've got Snapchat, we've got Google, we've got Facebook. And these entities that we've created over time have been a result of entrepreneurs saying, how do we take Web 1.0 and how do we capitalize off of it? How do we create something where we can make money off of it? It makes sense, right? This is a beautiful technology, and the initial aims for the web were beautiful. They were very pure. Let's take this decentralized internet that Tim Berners-Lee helped create, and let's create services on top of it, right? So let me take the server, right? And instead of having all of these computers talk to each other, which was very hard to do at the time, let me just make one central server. Let me use this HTTP protocol to create this get and set transfer protocol and store all of that data on this central server, like that, right? And it made it easy to do things like have an Amazon, have an eBay, have a marketplace, have a social network, have a ride-sharing service. All this stuff that we use today is because we were able to create these centralized services. It worked really well, and there were no problems. In fact, it was a faster way to do things, right? It was a faster way, it was a more efficient way. It just worked. But what's happened now is really bad. Objectively speaking, this is not my opinion. It is objectively a bad thing. And this is not just coming from me. This is coming from the creators of the web. Tim Berners-Lee, Jerome Lanier, the pioneers of the internet, don't like what has happened today, what the internet has become. How do we fix this? What does Web 3.0 look like? Not Web 1.0 or 2.0, not having centralized services, but decentralized services. The original vision for the web was to have decentralized services. In a good economy, we monetize more and more, but in a bad economy, we monetize less and less. What is the most valuable resource we have today? Can anyone answer that question? What is the most valuable resource that any person has today?
Knowledge.
Yes. Another word for knowledge is data. Data, exactly. But what are we doing with our data right now? We are giving it away for free in return for a free service, right? That's part of the terms of use for all of these services we use. Facebook's terms of service, Snapchat's terms of service. You let us use your data. We can learn from your data. We can profit off of your data. We can sell your data. And in return, we'll let you use a service. That's fine, right? It works. But what's happened is this is shrinking the economy because all of that data is being concentrated in these central servers, these connected cores that everybody has to connect through, right? These are gateways for the web. We need that data because as automation technology gets better and better, as we learn to automate all of these things, the only agency, the only power you're going to have in this new world that we're very fast moving to is your data. But right now you're giving it away for free. So what value do you bring to the world when you don't own your data? Nothing. Zero. You have no value. If you give away your data, you have no value. So you need to own your data and profit from your data, right? This is akin to something like a basic income. When robotics and automation technology and AI and deep learning and machine learning, when all of that gets good enough in the next 5 to 10 years probably, everything will be automated. Everything. Everything that can be automated will be automated. I just made that up on the spot. You call it my law. There's accountability as well, okay? So accountability is, we don't know what they're doing with our data, right? First of all, we want to own our data. We want to profit off of our data. Right now, we're giving it away for free, and they're doing something with it that we don't even know what it is. They don't have to tell us, right? They don't have to tell us what they're doing with our data. They could give it away to governments. They could use it to spy on people. I was having a conversation with a friend a few days ago, okay? We were talking about something, a single topic. Later on her phone, in the ad, it said the topic that we were talking about. They are listening on our phones. They are listening in real time. Facebook is listening. Our phones, they are listening to us. They are using that data because there are no checks and balances. That's just what's happened. They're so powerful. They're all around us. The Internet of Things is really a set of spy devices for these central authorities. And lastly, we are trying to solve AI. And I'm going to talk about that at the very, very end, but we're trying to solve AI, and we need a way to do that. And this is how we do that. All of these problems, a shrinking economy, data ownership, accountability, and towards general intelligence, all of that can be solved if we move to Web 3.0. So you guys with me? Like, we need to move to Web 3.0, right? This is the plan. How do we do this? So I'm going to tell you how to do this, okay? I'm going to tell you how to do this. I'm going to show you right now how to do this. You ready? Okay, here we go. It all starts with something very, very simple. The linked list. Who here has seen a linked list before? Awesome, yeah. Okay, so the linked list is a very, very simple data structure. I've got the code for it right here. Don't worry if you've never coded before, don't worry about it. It's only 12 lines of code. 12 single lines in Python. And what this does is it creates a data structure called a linked list. And a linked list is just a very simple object that's linked to the next object. That's linked to the next object. That's linked to the next object. And it just goes on as much as you want. And we can make one in Python. We'll just say class node. This is a class. This thing, this square. And let's give it some functions. Get data. Okay, that's going to give us what's inside of here, which is, if we could store it, the word hello. Get next. Get the next node in the list. Stack. Set data. What do I want to put in this thing? Hello, a number, an image, a video, whatever data. And set next. What's going to be the data in the next node in the linked list. That's it. This is a simple data structure. This is going to help us move towards Web 3.0. You might be thinking, wait a second, no, this has been around since the 80s. How is this going to help with anything? So let's take this linked list. Let's take this linked list, and let's store a copy of it on, let's say, 1 million computers. Let's just say, hey guys, I've got this linked list. I want you to store a copy of it. And inside of this linked list, we're not going to store the word hello. That does nothing for us. Let's instead store a transaction. And not just one transaction, several transactions. In fact, millions of transactions between people, payments. Let's store that. And let's try to make it so that no one can modify this linked list. No one can change the transactions in this linked list. How do we do that? Okay, what if we had a separate system of people, and all they did was they solved random mathematical problems with their computer, and this required a lot of computing power, like a lot. So much so that in order for you to be able to change any of the data in any of these nodes, you would have to have more than 50% of the computing power of all of those nodes that are solving these random mathematical problems. Now, what if the amount of computing power in those nodes was greater than the 500 fastest supercomputers in the world combined? Well, then you would have to have more computing power than the 500 fastest supercomputers in the world combined to change the data in this linked list. What that means is no one could change the data in this linked list. So if we did that, we had a linked list that everybody stored a copy of, that no one could change the data in, we would call it a blockchain. And that's what the Bitcoin blockchain is. It's a glorified linked list. That's it. It's a glorified linked list. And instead of calling them links or nodes, we call them blocks. And the reason it's called a chain is because it's not just pointing to a random node with the word hello in it. It's pointing to a random node with transactions in it. And the reason that the transactions are stored as this tree, decision tree to be specific, we can call it a Merkle DAG as well, we don't have to talk about that, is because that's just a more efficient way of storing it and retrieving from it. But you can just think of it at an abstract level as just a list of transactions. And that's a blockchain. So this is a very new idea, right? This was 8, 9, 10 years ago when Satoshi invented this concept. It was the first time where we could say, I'm going to store my transactions in this data structure. That's what the blockchain is. It's a data structure. I'm going to store my data in this thing, and no one's going to be able to modify those transactions. That's why we use banks, right? There are only a few real banks in the world that we trust enough to store our money in, or something very valuable, because we trust that they're not going to modify essentially the list of transactions in our account. They're not going to modify it. They're going to say, this is the amount you had before, and this is the amount you have now. Trust us, right? And that's it. We trust them. But what if we could store our money in a way that we didn't have to trust the bank, so there's not a third party? This is the first time that we've ever been able to do that, the advent of this data structure, right? That's cool. Okay, we don't need a bank. Great, so what? What else could we store in this thing besides transactions? We don't need to trust a third party to store our transactions. We don't need to trust a third party to store our data. We don't need to trust a third party to store our code. What about our web apps? What about our apps like Snapchat and Facebook and Google? What if we could store code in this thing, not just transactions? And that is what Ethereum's blockchain is. They took Bitcoin's blockchain, they added a bunch of other data like logs, difficulty, timestamps, mixes, but really what matters is this, the code. You don't just store transactions in the Ethereum blockchain, you store code. What that means is every computer, every node, remember it's a glorified linked list, every node in the network is storing code. Instead of pushing code to a single server like Heroku, right, that's how we usually build web apps, we store it on a single node that everybody has to agree upon. So in order to modify that code, you would have to have more computing power than the 500 fastest supercomputers in the world combined. So this is a trustless way to build web apps, and that's how we're going to get to Web 3.0. So what does code on Ethereum look like? Go back. This 17-line of code snippet is what you would call an initial coin offering. 17 lines of code is responsible for raising more money in the past 2 years than have been raised by every IPO in the past 10. We're talking about more than 100 billion US dollars worth of investment from the public. Every ICO that you're seeing these days is a result of this. Someone takes this, adds a variable that says how many shares or coins or tokens do I want, and how much do I want to sell those tokens for. They take this code and they push it to the Ethereum blockchain via a push command in terminal, or they could do it via a web app. And then they have this public address, 25 characters or more. And they say, here's the address, ICO time, invest. And then people just, 30 million in a single day. This kind of stuff happens. This is very powerful. And no one controls this, right? This is the advent of a new structure, similar to a corporation, a new type of institution that no one controls. And we can do this with Ethereum's blockchain because we don't have to trust a third party. Not just a bank, but even a government, legal documents, things like that. We can build these with smart contracts. Things every time we've had to require to trust a third party, we can remove that and push that instead in the form of contracts to the Ethereum blockchain. There's a problem though. So if you think about, okay, well, I'm going to make a web app and it's going to pull from the weather.com API and it's just going to tell you the weather. That's it, okay? So it's called myweatherappdecentralized.com. And all it displays is a single text, the weather today in Singapore. And it pulls that data from weather.com's API with the parameter Singapore now. It returns the result and it displays that, right? Whatever degrees Celsius. If we were to do that on the Ethereum blockchain, it wouldn't work. Why? Because every single node in the network has to pull that data at the same time, right? Because they're all executing that code at the same time. But the weather changes over time, right? So they would all have to agree upon the time. How do you do that? You can't, right? So the solution to this is to have what's called an oracle. And the oracle is a trusted third-party source that speaks to the web that the Ethereum blockchain can pull from. So you might be thinking, wait a second, okay, I thought this was trustless. What is the deal with this oracle thing? There are networks of oracles out there, delegations, 4 or 5 of them, and they can all agree on, they can have consensus on some data. But this is a solution to pulling data from the Web 2.0 in the form of APIs, until we have a better solution. But that's how it works right now. So you might be thinking, okay, we can have our application level constructs on the Ethereum blockchain. We can pull data in the form of oracles from the web. But then how do we store huge databases onto the blockchain? Could we do that? I mean, you could technically, but then every miner, everyone who's downloading a copy of this blockchain would then have to store all of that data on their personal computer. Facebook has a lot of data. If we were to decentralize Facebook and say, this is the Ethereum version of Facebook, everybody would have to store a copy of Facebook. That's just infeasible. So what we need is not just an application level construct that says, here are usernames, here are tweets, here are, etc. We need it to point to some kind of decentralized data store, a storage for data that is not owned by anyone. Now the best solution for this that I found is called the Interplanetary File System. So IPFS is big. There's a lot to go into about IPFS. It's a beautiful system the way it works, but essentially it's a group of computers that all agree on some data. So if I want to push some data to Google Cloud or AWS right now, right? These services own that data, right? So I would say, I've got some huge video, let me push it to Google Cloud or AWS, and they would store it. How do we decentralize that? With IPFS, it's a network of computers who are saying, I'm an IPFS node, right? When you push that video to IPFS, not everybody stores a copy of that video. One person will store a copy. That video will be split up into several parts and replicated across the network. So then you might be thinking, well, what if someone deletes their node? Well, there's already replications everywhere. How are these nodes incentivized? Well, there's this idea of Filecoin, where these nodes are paid to store this data. So it's how to incentivize these nodes. So that's kind of our complete list of solutions for this Web 3.0. We can have a data store called IPFS. We can have Ethereum to store code and application level constructs, and oracles to pull data from the web. This is how Web 3.0 works. This is the new stack. So this is how it works, right? Ethereum references content, big data, that's stored on IPFS. It gets that static content. The distributed application gets that content from IPFS, and it gets the global state for Ethereum. It's a global state machine. So if we combine IPFS and Ethereum, we can build these distributed, decentralized applications, right? But what's a talk? What is really a talk without talking about deep learning, right? Deep learning is where it's at. We've got this thing called a neuron in our brain. There's cells, billions of these cells in our brain, and they make us intelligent. They give us consciousness and love and emotion, all these things. We feel it because of this thing. It's a collection of them. I don't know how they work. Neither do you, neither does nobody. Neither does the most renowned neuroscientist in the world. No one knows how this thing works. But in the 50s, some guy was like, I get the basic idea. There's some data that's being fed into this thing. Something's happening here, and then it sends it out. And then very roughly, very, very roughly, he created a mathematical model for this thing. He said, we have these inputs. Let me just take these inputs. These are a set of numbers. Let me apply some kind of summation to this. And then some kind of nonlinearity, as in, let me take this data and make sure that it can learn a function that can learn any type of function, both a linear and a nonlinear function. That means any type of function. And then output a result. Right? So it takes some data, it does something to it, and then it outputs that data. And what happens here has been the topic of debate amongst many researchers, like what do we do to it? But the idea is the same, as where we take some input data, apply some kind of function to it, and then we have an output. And then we chain these things together. So we have a lot of them. And what happened is the deep learning revolution, right? All of these things that humans are good at, image recognition, driving cars, etc., all these things, for some reason, this model that resembles the human brain works well, sometimes even better than we do. So this is mind-boggling, right? On silicon, these chips, we roughly estimated the rules that are happening here, and it's doing something that even humans can't even do. Could there be some universal law of intelligence out there that we're just slowly approximating, that we're just slowly coming close to? Probably. And this is our first step there. Deep learning, incredible technology. Okay, so how do we combine all three of these things? How do we combine IPFS, Ethereum, and deep learning? Well, there's one really great example that I know of called OpenMind that a friend of mine has built with his community. But the idea is this. If I'm a data scientist and you have some data, if I want to train my deep learning model on your data, how do I do that in a way that involves no third party, where you don't have to trust me that I'm going to look at your data, say it's very sensitive, like patient data, like for hospital records. How do I train my model to learn from your data so I can make predictions about, say, cancer or some other disease without looking at your personal information? So this is a perfect example of how you can put these three technologies together. You can have IPFS store that data. You can have Ethereum build an application-level construct for smart contracts so that that data doesn't have to be stored on a central server. And you could use deep learning to learn from that data. So if you want to know how all three of these can work together, look up OpenMind. The website is openmind.org, but it's a great example of how to combine all these three things together. So where does this lead us eventually? This is a graph of emergent higher level complexity. Simple AI agents that are ants, but complex swarm behavior emerges. Right now we have AI, and they live on servers. They live in our phones, they live on laptops. But if we could free these AIs from the confines of servers and let them live in a decentralized space, they could speak to each other. They could learn from each other. And perhaps the real solution to higher level intelligence is to let that complexity emerge rather than trying to code it in. Why don't we just let it emerge, right? We don't know how consciousness works, but we have this basic rough idea of how it works. What if we just need to give it enough complexity and let that real intelligence emerge? We just can't even understand it. That is very likely the case. And if we use blockchains and we use Ethereum and we use IPFS and all of these decentralized technologies, we can create real artificial intelligences that are as smart, if not 100,000 times smarter than all of us. Lastly, you might be thinking, why would we want to do that? Why do I care about that, right? Water crises, the spread of infectious diseases, weapons of mass destruction, North Korea, Donald Trump, interstate conflict, failure of climate change adaptation, energy price shock, fiscal crises, unemployment, biodiversity loss, and ecosystem collapse. Some would say it's too late for us to solve climate change. It's too late. No matter what we do, we're not going to solve it. We are headed for destruction. We are headed for oblivion. There is nothing we can do. We're screwed. I don't think so. Because those people don't know about the power of AI, right? If we solve AI, let's just say we solve it. We create an intelligence that's as smart, if not smarter than all of us. We can give it an objective, a goal, a function. And that objective could be solve climate change. It would look at data in a way no human ever could, in a way that 10,000 plus scientists put together in a room for 100 years couldn't solve. It could solve all of these things immediately. It could move us towards this utopia that we didn't think even possible before, if we do it the right way. And if all of us together are thinking about ways to do this, we all have to be thinking about how these technologies work together. If you even barely understand how this technology works, it is your responsibility to do something about it. Because there are millions of people across the world who don't even have food and water, right? Sufficient, these in Maslow's hierarchy of needs, they don't have any of these things. How can they come to these kinds of insights? They can't. Everybody in this room, it's your responsibility to work on this, to help make this happen. How do you do that? You learn from the internet. You use this new university that we have, this collective university, to teach yourself, to educate yourself on how these technologies work and how you can best influence the problems in our world using these technologies. So, I want to leave you with a single remark. Solve AI or die trying. That's my motto, that's what I live by. And if you want to learn more, there's my YouTube channel, subscribe. Thank you very much.
Thank you, Siraj. I think we have the floor for 5 minutes Q&A. So, anybody have any questions? Yeah, I think there's only one mic.
So, okay, I can speak louder.
Yes.
Okay, the question is, the example that you saw, right, that we can, with IPFS and Ethereum, we can have a secure data access on that. So the algorithm can see why not the user that is accessing that data can see. So how the security is going to work there?
Yeah, security is definitely an issue we have to solve when it comes to decentralized applications. Part of the reason that we centralized stuff was because one person could just secure everything, right? It's much more secure to have data on a central server. Security is one really, really great area to focus on if you're looking on something to work on. It's one of those open fields. There's so much a startup could do there. Distributed security, decentralized security. In terms of a solution right now for security in general for decentralized applications, one thing could be better ways of storing data that involve replication. So replication is one example, right? A lot of times data is just lost in IPFS or something like that. It's just lost because there's not enough replication. So looking at different ways, different algorithms for replicating data that are efficient, that would be a great way to solve security.
That will solve the update security. Nobody can modify it. But if you want to provide the security on read access, like I'm not going to modify it, okay, that's secure enough because it has been saved on multiple places. But if I want to secure the read access that whoever is authorized and maybe authenticated already, that can only access the. So is it like Ethereum already provided, or we have to build a security layer on top of that?
We definitely have to build an extra security layer on top of it. Like there are ideas within these communities for IPFS and Ethereum for security layers, but we would need a different protocol entirely. Like one of these issues, one of the ways that this springs up is identity, right? We don't know who you are, we don't know how to authenticate you. Identity protocols as a layer on top of these data and application level protocols, that would be something that's very necessary. People have tried this. Microsoft even tried this with OneID. It didn't work. But the problem was they weren't thinking about it the right way. So you've got to think about it from a decentralized way. How do I make an identity protocol that can speak to these other protocols seamlessly? And there's this idea of cross-chain transfers, atomic swaps from the Bitcoin community. I think that would be a good place to look.
Thank you.
For inspiration.
Hi, so I was wondering what is the algorithmic scaling for the full homomorphic encryption? Because if I'm not mistaken, it's pretty large, and on top of that, most of the deep learning frameworks, the deep learning models tend to be computational hogs.
Yeah. So two questions there. One, how do we scale homomorphic encryption? And two, how do we solve the problem of deep learning being very computationally expensive?
They're together because we just increase the scale even more with the deep. If you're going to do homomorphic encryption on a deep learning system, it just goes crazy.
Yeah, definitely. Yeah, you know what it is. So there's this idea of one-shot learning where we learn from one or two examples. Like if we look at how humans learn, you give me an image of something that I've never seen before, and in 2 or 3 examples, I'll be able to classify it. Whereas with deep learning, it requires hundreds of thousands, if not millions of images. This is a problem. This is not even close to how we learn. I think the best example of a very data-efficient deep learning algorithm it actually came out of Facebook, and it was called the memory augmented neural network. So right now, we intertwine the processor with the memory in the neural network. That's the weight values, right? Those matrix weight values. But what if we could separate that memory into a separate module? And it could say, here's the memory module. It's just a glorified matrix. And then we have the weight values. Well, what happened when they trained this thing was it was able to recognize handwritten digits with only 15 examples. This was like 2 years ago. And then that project didn't get that much attention. It should have, because that was amazing. I would say, look at that project as an example. Facebook AI Research Omniglot dataset. It's going to be the first link on Google. But more efficient deep learning models is another open field of research.
I have 2 questions. So the first question is, I was wondering, how can we, as someone who's learning data science, adapt to the changes in terms of if we are looking it at a different perspective. So currently, for example, we are using some of the typical activation functions, which mathematically speaking are, like sigmoids and all these. These are mathematical models. So if there is any mathematical evolution such that, in future, perhaps it could be more than just the human brain, do you think that there will be a shift in terms of how we look at neural network or even the whole entire artificial intelligence space? And then the second question is, I'm just curious as to, AI these days, they have robots that can jump literally like a Terminator. So in terms of cybersecurity. I'm not sure how well it is, but what if one day it happens to be at the hands of maybe someone who's extremist or terrorist, say for example? Will we all be doomed because the weapons, everything can be controlled, and these robots might just go, it's mind-boggling to hear some of the robots talking about humans in a very negative way. If we've seen some like the one that has, I can't remember the name, the lady who has been yeah. So there was something negative about the way she thinks about human. So I mean, what if one day robots behave like this and they learn how to manufacture the mass weapon of destruction, or whichever way that they can behave like a Terminator, for example? I don't know how would it become of, so these are my two questions.
Yeah, okay, good questions. So for the first question about different ways of looking at a neural network in the future, beyond the model that we have right now. This is one of the most exciting areas of research in all of computer science right now. How do we evolve the neural network architecture? There's this idea of, well, let me just stack more layers. Let me change the weights. Let me add a new type of layer, right? And these are okay, this works. But what if we change the entire hardware? What if we said, instead of running it on silicon, let's run it on a quantum processor? What happens then? Does the brain use quantum processing? We don't know. There's this idea in neuroscience of quantum nanotubules, that's the seat of consciousness, that it actually lives in multiple dimensions. Who knows? But there's a lot of great research in hardware as well. So if you want to look at really, really, really different radical breakthroughs in neural networks, I would actually look at the hardware level, not the algorithmic level. On to your second question about Terminator AI. So some people say that the Bitcoin blockchain is, some people say that Bitcoin is one of those systems where you can sell drugs easily, and you can, but it's one of those systems that is very untraceable, right? This is not true. Bitcoin is the most traceable system in the world. Key example, Silk Road, right? The founder of Silk Road. Every single transaction is stored in a public way that everyone can view, right? They can view it, they can validate it, they can see exactly the trail of transactions. Now, what happens if we take these transactions and instead we abstract them to actions in a network? This person liked this tweet. This person did this with this money. This person launched this nuke, right? If we put everything onto this public ledger that everyone can view, that's a way to democratize read access to actions by everyone. So if there was some kind of government, right, for example, probably the Singaporean government would do something like this because they're awesome. Where they said, let me just make everything public and viewable by people, right? Then every politician would have to record all their transactions on a blockchain, right? There would be no more, there would be much less corruption. There would be much less, right? Because this would be validated by everybody. When it comes to nuclear weapons, weapons of mass destruction, if we are able to create these systems in a way that everyone can verify, there's more transparency, there would be less likely of a risk like that, right? Because these people would have to be held accountable. And that's really where this whole blockchain stuff plays in. It's all about accountability.
More questions?
Do you think that with all the work being done on like proof of stake and blockchain 3.0, there might be a better technology than Ethereum coming up soon?
Yeah, I do. There are some promising blockchains out there. I think one is Cardano, right? Charles Hoskinson was one of the former founders of Ethereum, and he's been working on that with a really great team. They're working on KYC compliance as a way to merge that with the existing financial infrastructure. It's great. I think the ideas that they have are great. And yes, there could be something better than proof of work for sure. I mean, proof of work is one of those really computationally expensive processes that wastes a lot of electricity across the world that could be put to better use. Why have these computers solve random mathematical problems? Why not instead have them solve protein folding or some real problem that matters? So yes, there's a lot of potential right now, however, in terms of building something that affects the population, that affects consciousness, that affects culture Ethereum and Bitcoin, these are ways of doing that very fast. And then we can update those systems later on.
Any more questions?
Do you think that reinforcement learning will work? As in, right now what I've seen so far is only on games, chess. Do you think it will have more practical purpose, like for example, the other classifier, all that stuff, that we can do something in the real world other than just playing games?
Yeah, right. Yes, I do. Well, the idea behind reinforcement learning has been around since the 60s. It's not new. All of those concepts that AlphaGo used last year, AlphaGo it beat the best Go player in the world, little refresher, and which was a huge deal because AI experts predicted that it would take 10, 20 years for that to happen. We did it in a decade less. All of the components of AlphaGo, Monte Carlo tree search, right? Value networks, policy networks, neural networks. These had all been around for decades. What was the difference then? Well, they just synthesized some ideas that hadn't been put together and fed it more computing power than we'd ever been able to feed it before, and then it gave us this result that no one thought possible. So the real breakthrough there was just giving it computing power. There was no difference in terms of the algorithms, just a synthesis of old ideas into one bigger new idea, which is how most of research works, to be real. But do I think that we could do better? For sure, for sure. I don't see why we aren't thinking of new ideas for reinforcement learning, right? There's so much we could do in terms of search strategies for reinforcement learning. There's so much we could do when we combine deep learning and reinforcement learning together. Games have been a test bed for AI because if we can generalize to different games, maybe we could generalize to tasks that matter. That's why these big institutions that have been focused on games, what they're really trying to do is apply it to real-world applications. Some examples would be cooling data centers. That's what Google did with the same reinforcement learning algorithm they used on a game. They used to reduce or increase the efficiency of cooling their data centers by, I think it was 40 or 50%, which is huge. That's one example, and that's just because Google did it. Guess what? Google open sourced that algorithm. If we look on GitHub and we see these reinforcement learning algorithms, we ourselves can take them and apply them to some use case, right? While these researchers at the top institutions are working on games because they're trying to improve the generalization ability, we can use them to solve problems today, right? So we can take those algorithms, we can use them to solve real problems. Some avenues, like maybe 3 that I can think of for reinforcement learning specifically, would be, for example, traffic control. That's a reinforcement learning problem, right? Reward, using an agent to take in a reward and then cycling that back into the system. Another one would be increasing the efficiency of bandwidth between applications, like peer-to-peer applications. That's another one for reinforcement learning. And a third one, I'm just making these up as I go. A third one would probably be, you know how Google did this with the data center? We could do that with just lights in general, right? Energy efficiency. That would be another one for reinforcement learning. All these ideas where we're talking about some event, some timeline, right? Where we are trying to increase the efficiency of something that's happening over time. That's a reinforcement learning problem, right? Because it's interacting with an environment. It's not an input-output static data set. It's a dynamic environment. So think about an environment, think about time, think about sequences, and apply reinforcement learning there.
Thank you. Okay, we'll take one last one.
So you mentioned earlier about how you can have individual simple AI on a blockchain and they can all communicate with each other and they can come up with some sort of emergent behavior, right? And that's the next step. What if we don't like the emergent behavior? Because you can't control swarm behavior, right? Like ants in a colony, individually you know what they do, but you don't know how to behave in a system. So what then?
That's a great question. So I met someone who worked on the ethics team at DeepMind. And she was telling me that, she was kind of going through this game with me. She was saying, well, why should we release this source code? Why should we do this? Why should we do this? But the conclusion that she made me come up with, which is what the conclusion that she had already come to, the thought process, was that DeepMind wanted to be the first to come up with the real intelligence. They wanted to be the first to solve AI because they knew that they themselves would be benevolent with it. They didn't trust that other people would. So that's why they didn't open source it at the time. However, that's not good for us, right? Because if someone at DeepMind is not benevolent for whatever reason, they could use that AI for evil, by whatever your means of evil is. How do we prevent that? The best way to prevent any kind of malpractice, any kind of malintent, is to democratize this technology, to give it to as many people as possible. There's a famous quote by this English playwright, Lord Acton, also by Elon Musk. But the quote is, the best way, and I'm paraphrasing, the best way to prevent the rise of a despot, someone who is an all-powerful dictator, is to democratize access to power. And the easiest way is to centralize that power. So if we decentralize this power to AI, to blockchain, to all this technology, to data specifically, then we can better increase the probability or likelihood that we reach a good state in the future. Is there a possibility that someone who is a bad actor will use this technology? For sure. I mean, life is full of existential risks, right? But doing this, democratizing these technologies, further increases the probability that that won't happen, because we'll come up with some sort of security system or fail-safe or check system that would prevent that from happening. Maybe there's a decentralized AI that goes rogue. Well, there might be a decentralized security system that prevents that someone created beforehand. We just all have to be thinking about these things. It's good. It's a good thought.
Okay, that's all. So yeah, I'm always grateful for all those speakers that share their time for free. And I know, like this time around, Chirag was coming here with an intention. So let's put our hands together and thank Chirag. Lucas, do you need to say anything? Lucas, do you need to say anything? Okay, okay, whatever. So anyway, we'll be here for a while for networking and stuff like that. So as usual, thank you very much for coming.